it back, it's subtraction now. So we did adding previous day, now we'll do subtracting of polynomials. You know what? Adding, subtracting, they go hand in hand. So a lot of the things we did for adding, we'll do the same for subtracting. You're going to combine algebra tiles that represent each polynomial. This time, instead of using the sum principle, we're going to use the difference principle or the subtraction principle to simplify the results. Okay? So once again, I want to show you using algebra tiles, and then I'll actually do it with you without. So let's use algebra tiles to do the following. Okay? Notice I'm now asking you to take this polynomial, 3x squared plus 4x minus 3, and from it I want you to subtract x squared plus 2x minus 1. So we'll begin by modeling the 3x squared plus 4x minus 3, and I did that for you. Say thank you again. Whee! Right? 3x squared, 4x's, and then minus 3, the 3 shaded small squares. So from these tiles, what I'm asking you to do now is let's subtract or remove the tiles indicated by the second polynomial. So that's the stuff in green. So notice I'm going to subtract one of the x squared tiles. So 1, and I'm going to write down the word positive x squared tiles. That's this. I'm going to actually subtract from it also 2 positive x tiles. And then finally subtract 1 negative x tile. So subtract just means remove. So I'm going to ask you now to take this picture, and this is the one I copied. So once again, this is the original. And now let's do the following. Let's remove. So let's remove. Remove 1 positive x tile. Goodbye. Remove. Remove 2 positive x tiles. Goodbye. Remove. And finally, 1 negative tile. Goodbye. Remove. And so what do we have left? I see the 2 large squares. I see 2 rods. And I see 2 shaded small squares. And that, dear friends, is your answer. So the remaining tiles represent our solution. 2 large squares are 2x squared. 2 rods, that's 2x. And then 2 shaded small dark squares, that means it's minus 2. Seems quite simple, right? But this was nice because we had all those things there. But there's a trick that you need to know when some other problems arise. So let me show you one more on the next page. So please turn the page. Okay. I'm going to ask you to do the same thing. Use algebra tiles to do the following. Okay? And this time, I've got these 2 polynomials. So negative 3x squared plus 2x minus 4. I'm going to take away from it x squared minus 3x plus 2. So again, I'd like you to begin by modeling the first polynomial, meaning drawing it out. And once again, say thank you. I've done it for you already. Yay! Now, according to the second polynomial now, the one in green, we're going to have to remove the following. We're going to have to remove 1, and I should have written down positive x tile, or x squared tiles. And then I'm going to remove 3 negative x squared tiles. And then 2 positive 1 tiles. Now, can we do this? I only see negative x squared tiles, but I'm supposed to remove 1 positive one. I don't even see it. How do I remove something I can't see? Same thing with here. I see 2 positive tiles, but I'm supposed to remove 3 negatives. I can't see it. I can't see it. How do I get rid of it? And then over here, 2 positive 1 tiles, the 1 small squares. I don't see any positive 1 square tiles. I'm in trouble. So, it's not as simple as the previous example now. But to fix this, here's the trick. We need to add the tiles that we need to remove to our current diagram in the form of 0 pairs. You're like, what? Yeah, I'm going to ask you to add the tiles that we actually need to remove in the form of a 0 pair. So what I mean by that is this, okay? Looking at our green polynomial here, okay? X squared minus 3x plus 2. I'd like you to draw that out. That's right here. Okay? This is our x squared. Here's our minus 3x. And there's our plus 2. Right? Got that? But I want you to write it in the form of 0 pair. So you have to match it up with the corresponding tiles of different color. So the zero pair becomes the following. You see how the x squared now matches up with this negative x squared? Okay, so that creates a zero pair, right? And then the negative 3x matches up with the positive 3x, another zero pair, okay? And then finally the positive 2 match up with minus 2, another zero pair. So this entire expression here represents my zero pair of the second polynomial. Okay. So in essence, what I did was, the top here is x squared minus 3x plus 2. The bottom is negative x squared plus 3x minus 2. Together they form the number 0. Okay? And so now, once you've created your zero pair, I'd like you to put it with the first polynomial. Okay, so here's my zero pair that I'm going to redraw here. Okay, this is my zero pair. And then over here on the left, this is just my original polynomial. Okay, so original or first polynomial. And now, together, I can remove the tiles that are required. So now look at this together, okay? Look at this now as one large thing, and then together our goal was to, yes, subtract 1 positive x squared. So I'm looking at the green part right now. 1 positive x squared, 3 negative x tiles, and then 2 1 tiles. So let's get rid of that, right? Let's remove the 1x squared. Goodbye. Let's remove the minus 3x. Goodbye. Let's remove positive 2. Goodbye. And what do we have left? Let me draw. 1, 2, 3. Shaded big square. Oh, a fourth one now. 4 shaded big squares. The 2 rods. After that, the 3 rods that are all in white. And finally, the 4 small squares that are dark, along with 2 other squares here. So what is my algebraic way of describing this set of algebra tiles? I've got 1, 2, 3, 4 x squareds, but they're dark, so it's negative. I've got 1, 2, 3, 4, 5 rods, they're white, so they're positive. And 1, 2, 3, 4, 5, 6 negatives. There you go. And that, dear friends, is your answer. Okay? And you're like, whoa, drawing these tiles, major pain. Yeah, but I don't always want you to subtract with algebra tiles. I do want you to understand how to do it, though. So let's now turn to page 3. And how do we find ways to do this algebraically? Well, whenever you're subtracting, you might have seen this idea of adding the opposite. Well, the same thing applies to the polynomial. That is, what you're doing is you're changing the subtraction sign to a positive and then adding the opposite. And in essence, that's what we did with our last example here. Notice what we did. We were adding, because we combined them together, the yellow and the purple together. And then remember, when you subtracted, we just got rid of all those. And we were left with the actual opposites, and we just combined them all together. So in essence, what we just did in example number 2 is what we're going to do with algebra. We're going to add the opposite. But before we try that in example number 4, let's just quickly figure out what the opposite are for each of these polynomials. Example 3a, I said, here's 2x plus 3. What's the opposite of 2x plus 3? Yeah, change everything to a minus. So minus 2x, or negative 2x, minus 3. Same thing for part B. So I got negative 3x plus 5. Change that to positive 3x and minus 5. That's the opposite. Similarly for part C, the opposite of negative 3x squared. That's just positive 3x squared. Minus 6x. And then plus 8. And last but not least, the last one, negative 4x squared plus 2x plus 1. Alright, so now let's try to subtract the following. And remember, the key thing here is just to add the opposite. So we're going to keep the first polynomial the same. We're going to change the minus to a plus, and we're going to make it the opposite. So what's the opposite of negative 2x? That's positive 2x. What's the opposite of positive 6? That's negative 6. Okay, so in essence, we're distributing the negative sign into both those terms, and now making it an adding equation. This is just 4x plus 8 plus 2x minus 6. Combine like terms together, so 4x plus 2x, 8 minus 6. One last line here, 4x plus 2x is 6x, 8 minus 6 is 2. Now, I know I did a lot of steps. If you can skip a few, you can try, but if you make a mistake, I can't help you. Alright? So do what you need to do. I'm going to ask you to try parts B, C, and D, and we'll come back and do one more example. So, once again, I think you know enough. You should be able to pause the video, work on the questions, come back and check your answers. Remember, subtracting is the same thing as adding the opposite. Adding the opposite. Adding the opposite. Adding the opposite. Subtracting is the same thing as adding the opposite. Adding the opposite. Adding the opposite. Do 3x squared minus 2x squared. It's just x squared. 5x plus 5x is 10x. Negative 6 plus 6 is 0. Subtracting is the same thing as adding the opposite. Adding the opposite. You getting tired of me saying that? Adding the opposite. Okay, and then finally, just like how when we did adding, we could use this column form, we can do the same thing for subtracting. Just be a bit careful. So same idea, let's line them up. So negative 5r squared minus 2r minus 7. And then underneath, let's put 2r squared plus 3r minus 3. And once again, let's put a minus sign in front, and we're going to subtract. Okay? This time I'm actually going to subtract left to right. Once again, it doesn't matter, but I'm going to do it left to right. Make sure you keep the columns aligned. So the first thing I want you to do is this part here. So negative 5r squared minus 2r squared. So here's what I said. I said minus 5r squared minus 2r squared. Negative 5 take away 2 is negative 7. So negative 7r squared. Next part here, negative 2r take away 3r. So hear what I just said there? Negative 2r take away positive 3r. So taking away a positive, adding the opposite. Negative 2 minus 3 is just negative 5. So that's negative 5r. And then finally, negative 7 minus negative 3. So once again, negative 7 minus negative 3. Adding the opposite, so negative 7 plus positive 3. Negative 7 plus 3. That's negative 4. And there is your answer.